Hey, Algebra 2, today we are going to be doing more work on square root equations. Yesterday, I hope you did your work because you're going to need all those skills today because we're going to make it a little more complicated today. This is the last unit, or the last section of this unit, and then we will have tomorrow, on Friday, we'll have a review, and then Monday we will have the test. So with that said, this is hard, and you have to recall past skills. And if you're wondering what factoring I'm talking about, you don't have to write this down, but I'm going to show you. Factoring involves that thing where, like, if we had like this, okay, cool, I moved that. Let me get the writing utensil. Where if you had something like this, hey, we got x squared plus, I don't know, 13x plus 36. You'd have to do that whole ABC thing, A, B, C, then AC, right? A is at this point 1, B is 13, C is 36, and AC is 36. So you'd have to find from this example what multiplies to 36, what adds to that. So in this case, you'd end up with a 9 and a 4 as your factors, and you'd end up with x plus 9, yada yada, x plus 4. And again, not very great example, but just showing you that. And then when you have this, you get to this place, you can go ahead and solve. And how you do that is you check for each one separately. So I set x plus 9 equal to 0, and I solve it, which gives me x equals negative 9. And if I did the same thing for x plus 4, I'd end up with x equals negative 4. So that's a little retouch on the ABC, AC factoring thing. You'll see where it comes into play. Now, remember my whole opinion on notes with tons of written stuff on here? Normally, it's not my favorite, but y'all, these notes are fantastic. They give you step-by-step play on how to do this. I mean, they're just great. So even though it looks like a lot, just do what you can to read it. Step 1, step 2, step 3. I'm going to go ahead and work immediately an equation. Example 1. All right, I'm going to break this down and show what we've done here. If we paid attention at all yesterday, this should be kind of a repeat, kind of a breeze. Let's see what we got here. Example 1, what happened? Well, look what happened from here to here. A is, first of all, given equation. So let's have that written down. Given equation. Man, I wish I could get my digital handwriting better. Given equation. What happened there? We moved the 3 over. So what did we do? We isolated the radical value. We got the radical on one side and everything else on the other. Now keep in mind, if you had 2 radicals, right, you may have to have one radical on one side, one on the other. But in this case, when there's only one radical, you get it by itself. So get radical by itself. Get radical alone. Get radical alone. My God, my horrible digital handwriting. I should feel bad about myself, and I do. So now that we have this one right here, B, and how do we get that alone? We just moved -3 on both sides, -3, -3. Y'all need to start recalling some of your algebra. I know I break down the steps for y'all a lot, but come on, you just -3 on both sides. Now, we get to this place, and we're going to remove the radical by squaring both sides. And look what happens when we square both sides. So now we're going to say square both sides on here. And again, the reason we're doing it is to remove the radical. Square both sides. It's not like we're just randomly doing it. Square both sides, and then what ends up happening is the radical gets removed. So you can see right here, this square root and this square cancel out. We're left with 5x minus 9. But remember, when you square a whole parentheses, it's the whole parentheses that gets multiplied into each other. Now, this is one of those things, and I'm going to do it in red. This has been taught to y'all freshman year. This has been taught to y'all in my class multiple times. And I'm still going to have kids say they've never seen this in their life, and that's fine, but just don't say that around me because you have seen this. So whenever you do this, check out what happens here. So on this line, hold on, let me actually finish the instructions. On this line on D, what did we do here? We squared both sides. And then, yeah, that's really it. How did we get from C to D? What did I want to write in that one? Oh, expand factor. That's what it was. Expand the factors. And what does that mean? That just means write the factor twice. That just means write it twice. So do you see how we had x minus 3 squared? We ended up just writing it twice down here. X minus 3, x minus 3. Okay, now, how did we get from D to E? We did distribution, y'all. So, I need to switch it back. we did distribution. We went from x times x. So remember this. You go x times x. There's your x squared. X times minus 3x. Cool. There it is right there. Another minus 3x. Then we're going to go and repeat that. But this time to negative 3. Negative 3 times x. There's your other negative 3x. And then negative 3 times negative 3 is positive 9. So that's what we did here. So I'm going to write in red, distribute. It's the, what's it called when it's two of them together? Well, distribute. We've been calling it distribute. It's been called foiling before, but really it's just fancy distribution. Distribution. And in this case, you have to basically get it all the way there. That's where this comes from. So if you're stuck between D and E, do yourself a favor and try to remember this. All we did was multiply everything together. X times x, x squared. X times negative 3x, or 3, there it is, negative 3x, etc., etc. All right, now check out what happened on F. Basically, by the time we get to F, what do? They combine like terms. Combine like terms. Combine like terms. And this kind of makes sense. Like, when you get into your own rhythm of doing this, this isn't going to be, you're not going to think in these terms. Combine like terms. So negative 3x minus 3x is minus 6x. So that's where that came from. Now, from this line, from F to G, what happened? We set everything equal to 0. So how did we do that? Well, I subtracted the 5x first. So now when I have my minus 5x right here, minus 5x there, minus 5x there, that cancels out. And then negative 6 minus 5 is negative 11. We also subtracted out the 9 on both sides. And the way we did that was by adding it, because this says minus 9, so I have to add it to both sides. 9 plus 9 is 18. This is just basic equation work, y'all. So what do? We set equal to 0. And you have to use your skills in order to do that. You can't just write a 0 down and hope for the best. Set it equal to 0. Move stuff around. Now you have to factor right here. This is where we have to get into the fun part. I'm going to take us over here and factor. You have to factor this out. How do you factor x squared minus 11x minus or plus 18? Remember this, A1. Let me get this equation written up here. X squared minus 11x plus 18. This is a longer video than I wanted. Step G. Factor this out. A is 1. A is the number in front of there. B is negative 11. C is 18. And A times C is 1 times 18 is 18. So what multiplies to AC but adds up to B? In the interest of time, I'm going to go ahead and just tell us. It's negative 9 comma negative 2. Negative 9 times negative 2 is in fact positive 18. Negative 9 plus minus 2 is in fact negative 11. So we found x minus 9, and x minus 2. So how did we get to step H? We factored. That's all we did. Factored. And now solve. You now have to solve each one. How do we do that, y'all? You just take each little equation and set it equal to 0. So I have x minus 9 equals 0. And by the time I solve it, I'll end up with a positive 9. Then I set x minus 2 equal to 0. And by the time I solve it, I will have a positive 2. So I end up with my potential answers of x equals 9 and x equals 2. Now check extraneous solutions. Check extraneous. I'm just going to write extraneous because I'm lazy. Extraneous. And that means go in and plug it in. Look what happens when you have your... So yesterday I talked about taking the square root and it being plus minus. This is one of those tricky things. When you take the square root, when there's no squares originally inside the equation, like in here, there's no original squares. When you take the square root, today you're only taking the positive value. You're only taking the positive value today on here. Again, I hate that, being that math teacher that's like, why does it matter some days and not the other days? In this particular case, it matters because we're introducing the squared. We are introducing the squared, which would introduce a plus minus. But since the original equation is only a square root, we only want the plus. It's weird. Just trust me when I say we only want the positive square root. So when you plug in your numbers, let's see, on this one, you get 5 times 9 down here. I'm right over here, minus 9. 5 times 9 is 45, minus 9 is 36. The square root of 36 is, in fact, 6. So 6 plus 3 is 9. Does 9 equal 9? Yes, it does. You got to work that out. You can see the steps kind of worked out here. Then they plugged in 2. We get 10 times, what's it called? 5 times 2 is 10, minus 9 is the square root of 1. Square root of 1 is just 1. So 1 plus 3 is 4. Does 4 equal to 2? No, it does not. So that's basically how you plug this in. And if you have any trouble doing that, I will help you in class. Ooh, this video went way longer than I wanted.